This is number 6 from the 2001 BC exam. We're given the function f as defined as a power series, and in part A we're asked to find the interval of convergence. So to do this, we're going to use the ratio test, and that is going to be the limit as n approaches infinity of the absolute value of a sub n plus 1 divided by a sub n. So we plug in n plus 1 to our general term, and then we are going to multiply by the reciprocal of the general term that we're given. Our x to the n and our x to the n plus 1 cancel, and then so do the 3 to the n plus 1 and 3 to the n, so we're just left with n plus 2 times x over 3 times n plus 1. N plus 2 over n plus 1 will go to 1, so then we're just going to be left with the absolute value of x divided by 3 is less than 1, and then we multiply both sides by 3, and then we just get the absolute value of x is less than 3. Now that we have the radius, we're going to check for convergence at the endpoints, so we're going to plug in 3 and negative 3. First, for x equals 3, we're going to have the series from n equals 0 to infinity of n plus 1 over 3 to the n plus 1 times 3 to the n. 3 to the n is going to cancel on the top and on the bottom, so we're going to be left with a series from n equals 0 to infinity of n plus 1 over 3. Then we're going to use the divergence test, so limit as n approaches infinity of n plus 1 over 3. This is going to go to infinity, so that means it's going to diverge by the divergence test. Now we plug in x equals negative 3. So then we have the series of n plus 1 over 3 to the n plus 1 times negative 3 to the n. This is going to give us an alternating series. It's going to be the same as before, except with the negative 1 to the n. So then we're going to be using the alternating series test. So we're just going to use the limit as n approaches infinity of n plus 1 over 3 again. And that's going to go to infinity, and then we can say that it diverges by the alternating series test. So now we know that since it diverges at both of the endpoints, the interval of convergence is just going to be from negative 3 to 3 in soft brackets, so excluding negative 3 and 3. So part B asks for the limit as x approaches 0 of f of x minus 1/3 all over x. So first we're going to plug in the given function for f of x. So since the constant in f of x is 1/3, we can just subtract 1/3. And then all the rest of the terms have an x, so we can just divide the top and the bottom by x. Now we're going to have the limit as x approaches 0 of 2 over 3 squared plus 3 over 3 cubed times x plus 4 over 3 to the 4th times x squared, dot, dot, dot. Then all of the terms with x are going to go to 0, so then we're just left with 2 divided by 3 squared, which is the same as 2/9. Part C asks us for the first 3 non-zero terms of the integral of f of x from 0 to 1. So we plug in f of x. Since it's a polynomial, we can just take the antiderivative, so undoing power rule, add 1 to the power of x, and then divide by that power. So we're going to have 1/3 x plus 1/2 times 2 over 3 squared times x squared, plus 1/3 times 3 over 3 cubed times x cubed, dot, dot, dot. Same thing for the general term. So it's going to end up being n plus 1 times x to the n plus 1 all over n plus 1 times 3 to the n plus 1, and then the n plus 1 on the top and bottom are going to cancel out. Once we cancel everything, we're left with 1/3 x plus 1 over 3 squared x squared plus 1 over 3 cubed x cubed plus x to the n plus 1 over 3 to the n plus 1, all from 0 to 1. Now we plug in 1, and 1 to any power is still going to be 1, so we're just going to have the coefficients all added together. If we plug in 0, all the terms are going to end up being 0, so we don't even need to really show that. So we're just left with 1/3 plus 1 over 3 squared plus 1 over 3 cubed plus 1 over 3 to the n plus 1. Finally, for part D, we're asked for the sum of the integral that we just found in part C. So we can write that out, 1/3 plus 1 over 3 squared plus 1 over 3 cubed, dot, 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 plus 1 over 3 to the n plus 1. And if you notice the pattern, this can be written as the series from n equals 0 to infinity of 1 over 3 to the n plus 1, or 1/3 all to the n plus 1. Since 3 to the n plus 1 is always going to be greater than 1 to the n plus 1, this is a geoseries, and we can find the sum of these pretty easily. The sum is just going to be the first term divided by 1 minus r, and r is going to be the rate from the first term to the second term. So for the first term, we plug in n equals 0, and we get 1/3, and then for the second term, we plug in n equals 1, and we get 1 over 3 squared. The first term is 1/3, and then to get from the first term to the second term, you just multiply by 1/3, and that's going to be the r. Finally, we plug into our sum equation, so it's going to be 1/3 divided by 1 minus 1/3. That's going to be 1/3 divided by 2/3, which simplifies to 1/2. Thanks for watching. I hope this helped.